everybody. Today we are going to be talking about work/power. And stay tuned after we talk about these things to talk about mechanical advantage. So, first thing on our list, work/power. Work. What is work? Transfer of energy that occurs when a force makes an object move. Work is measured in joules, and our equation before we finish that is W equals FD, which is W is your work, F is your force, and D is your distance. Now, when you are finding these things out in an equation that you are doing, such as this one we have here, you need to know whether if you're looking for force or distance or even work, that you need to put your units in form. So, force, if you're looking for force, you're going to put your newtons, and for distance, you're going to put meters. Now moving on to our little equation. You push a chair with a force of 100 newtons. You move it a distance of 5 meters. How much work did you do? So, we're going to fill it in. It does say how much work did you do, so we don't know how much work we have so far. So you're going to put your question mark here, and then 100 newtons, which you're going to put for your force. So 100, excuse my bad handwriting. And then your distance, you have 5 meters. 5 meters. So, in order to figure out this problem, you're going to plug it in. So, you're going to put W equals force times your distance, which is 100 newtons. You can use a small n, times 5 meters. And once you've done that, you're going to calculate that. So when you plug that into your calculator or do it on your paper, you're going to get 500. And since we are talking about work, you're going to put the J for joules. And that is going to be your final answer. Moving on to power. What is power? The amount of work done in 1 second. And then the unit for power is watts, and the equation is work over time. Work is, since we've already done that, it is in joules, and time is measured in seconds. Our equation is P equals W over T, just to shorten it up, and I just got some color in my hand, but we lived through it. Alright, so our power example we have here is you do 900 joules of work pushing a sofa. Sorry, I wrote that off. It took you 10 seconds to move it. How much power did you use? So, the first thing that we have to find is our work. And if you look up here, it says 900 joules. I'm sorry if you can hear the music in the background. My sister is playing music. Yeah. So we have 900 joules. So you're going to put your 900 here. You can put the J if you want, just if it helps you. Just to remember, excuse my terrible J. And then your time that you have is 10 seconds. So, you put your 10 here, and put it SC or just S. Okay, so, and again, we don't know what power is. So you're going to plug that in. P equals 900. I just like to put the units in there as well, just so it reminds me. And then you're going to put your time in, because our denominator is going to be your time. So you need 10. Let's do this just to remember. And when you plug that in, power is going to equal to 9. Your power is going to equal to 9. D.
90 what?
Good question. Well, since our power is measured in watts, you can put your W there, or you can just write out watts. And now that we've done that, let's move on to mechanical advantage. Hey everybody. Today, again, welcome back. We are going to be talking about mechanical advantage. And for that, the things that equal mechanical advantage is your input force and your output force. And the input force is the force applied to a machine. And that's how you write it out. And your output force is the force applied by the machine. And that equals that. And so our okay, so we're gonna,
What does that mean in red? Ideal machine. I don't understand.
well, that equals to your input force. That is going to equal to your output force. So
Does that mean it's perfect? I mean, like, what does that mean?
that means that they are perfectly equal to each other. So we're going to come back to this one, and we are going to our problem. Let me grab my marker, and our problem is, when removing a nail from a board, you apply 50 newtons of force onto the hammer. The hammer applies 50 newtons of force onto the nail to remove it. What is the mechanical advantage? Well, it's not always going to equal the same amount, so you might need to do some math on that. But since we are very lucky on this problem, it actually is going to equal the same thing, because it says you apply, oopsie, we are going to apply 50 newtons, so that is going to be your input force, and your F out, which is your output force, is also equal to 50. Your mechanical advantage, so what you're going to do in order to find that, like up here, your mechanical advantage is going to equal your output force divided by your input force, which is measured in newtons. So what you're going to do is 50 divided by 50. And that is going to equal 1. So,
One what?
mechanical advantage is going to equal 1. But we have to put our SI units, and your units is going to equal
Isn't it newtons? Because everything else is measured in newtons.
newtons. And let's come back up here. A machine cannot create energy. So work output force is never greater than your work input force. So
is that like saying, since the output and the input are the same, is that what you call an ideal machine, that example?
yes. Well, since we've done that, let's review. Mechanical advantage. We've talked about our input force and output force. We've talked about an ideal machine. And we've done our equation. Come back for more learning.